So we've got a plane with a given equation. Determine the equation of the line that passes through the point 1, negative 1, 1 and is normal to P. Okay, so how do you do that? Well, let me just draw a little picture. So what you want, let's say that's the plane P, you want the line that is basically normal to that plane. Okay? So it's passing through the plane and it's normal to the plane. Okay, so I'm going to use I'm going to come up with the vector form or parametric vector form of the line, which is something you learn in first course in vectors, right? So what do we need for the equation of a line? We need say a point on the line and a vector parallel to the line. Okay? So, we already know a point on the line that we want. It's got coordinates 1, negative 1, 1. Okay? So let's say a point A on the line and a vector V parallel to the line. So here, A is just 1, negative 1, 1. How can I compute a vector V that's parallel to the line? Well, it comes down to the equation of the plane. I can look at the equation of the plane and always compute a normal vector, okay, just by looking at these coefficients. Okay, so remember a vector that's normal to the plane is just perpendicular to all the vectors already in that plane, okay? So a normal vector to the plane cal P is, all you do is you look at the coefficients of x, y and z and you take out the coefficients and write them as a vector. Okay, so let's call this say n. So this is what we want for our v. So let's let v equal that, and then I can come up with my equation. All right, so the parametric vector form is just this. Actually, I'll do it with t's here, because make t the variable. Sometimes you do it with lambdas. Let's just do it with t. All right, now what's this? This is just a position vector of that point there. So you take that, you write it as a column. Okay, so it's going to be 1, negative 1, 1, plus t times that. Okay? Now if I wanted to write this out, by this x vector I mean x, y, z. Okay? So the parametric vector form of the line that goes through that, through the point 1, negative 1, 1 and is normal or perpendicular to this plane, has this parametric vector form. Okay? So if you want to do it in the coordinate form, you would have x equals 1 plus 2t, y equals negative 1 plus 3t, z equals 1 minus t. Okay? What happens if you wanted the Cartesian form? You don't want the vector parametric form. Let's say you don't like vectors. How could you change that to a Cartesian form? Anyone know? Well, what you would do is take the three equations, x equals 1 plus 2t, y equals negative 1 plus 3t, z equals 1 minus t, make t the subject and eliminate all the t. So you've just got the equations involving x, y and z. Okay? It'll be something like x minus 1 all over 2 equals y plus 1 all over 3 equals z minus 1 all over negative 1. That'd be the Cartesian form for it. Okay, so depending on what you like, you can express it in different forms.